Hello everybody and welcome to our indoor testing. We previously did an outdoor to show that the system can work anywhere, but the purpose of this video is to show the real-time aspect of the system, how the data is sent in real time, how the timestamps are the same both in the Raspberry Pi and the Android, and to show how it operates and communicates between the Raspberry Pi and the Android app. This is our system right here. We have the ultrasonic sensor, the Hall effect sensor. I'm going to trigger it by moving my hand and triggering the Hall effect sensor with a magnet. We have a car plate right there in the UK that's going to be captured by the Pi camera once the ultrasonic sensor gives us low distance and high velocity, and the Hall effect sensor is going to give us huge bike velocities. This will trigger the camera to take the picture. Now, as we are recording the screen here on the application, we can notice several things. 3 graphs displaying the car distance, the car velocity, and the bike velocity, which are blank now because the system has not been running yet. And in the results section, we have a picture of the last test case. So what's nice about the Android app, it displays the information about the last test case. The picture, the car plate recognized, the car distance, velocity, and bike velocity at the moment that the image was captured, to show more the real-time aspect of our system. And in the end, we have a link to the government UK registry of cars where the user can upload the car plate and get the information of the cars to alert the authorities. Now, the Raspberry Pi is awaiting for the mobile connection. This is because it is awaiting for a UDP broadcast message from the mobile app. This has been done to have no hard code anywhere in the system. So a user can use any mobile app being connected to the Raspberry Pi and to the same Wi-Fi, and the user does not need to go and change the IP address of the mobile app whenever he uses a new Android phone, because it is all in dynamic and real time. Now once I press connect, it sends the UDP broadcast message with its IP address, the phone's IP address, and the Raspberry Pi can thus connect. And here we can see several stuff. We have the timestamps from the Raspberry Pi, which are being sent through the socket to the Android app and displayed there to ensure real-time system. As I said, the timestamps are all correlated and coordinated together. We have the car distance, car velocity coming from the ultrasonic sensor, and the bike velocity coming from the Hall effect sensor, which is 0 now because it has not been triggered yet by the magnet. But once I trigger it, hover, imitating a car, and hover against the ultrasonic sensor, we can see that the bike velocity goes up, the velocity of the car goes up, and the distance goes down, triggering the camera to take a picture, capturing it, and sending us the new updated one. Everything is done in real time, and here we have a picture of the car, the car plate recognized, the car distance at the moment the image of the car has been captured, velocity, bike velocity, and then we can enter the car plate information. Now, in parallel, what happens is that the Raspberry Pi uploads the car image to Firebase, and the Android phone extracts that image from the Firebase Google storage. However, the car plate, this car distance, velocity, and bike velocity are sent through the socket at the moment that the image was captured, hence ensuring the real-time aspect of the system. Now, if we go to the Firebase, we can notice the same bike velocity, the same car velocity and car distance, and the same car plate. And if we go to the storage, go to images, we have an image of the car plate. So Firebase is a real-time database that is being used by the system. Now the API is not that accurate because it is open source and we are using a mobile phone to display the car plate. But several test cases can be done to ensure that the car plate is correct. Now we take another triggering camera capture, and thus we can see that it captures the image, sends the relevant information through the socket, and sends the and sends the information of the car plate to the mobile app. And here we can see that the API actually recognized the car plate correctly. And what a user can do is he can log in to that link. The user can plug in the car plate information in this link right here. And what we're going to do is we're going to plug in the car plate information, which is YM55UYE. And once we continue, we can see that the system actually gives us the information of the car, date of registration, the vehicle make, and every relevant information needed to alert the authorities about this dangerous act that the driver committed. This is our final demo for this project. Thank you for watching, and we'll keep you updated on any new news.